Service provisioning in the telecom world. Service provisioning is the critical bridge between a customer's purchase and the actual activation of technology in the network. In 2026, this process has evolved from manual configuration to intent-based, zero-touch automation. The process is generally governed by the TM Forum Business Process Framework, ATOM, and is divided into three major operational layers: BSS, Business, OSS, Operations, and the Network. The order-to-service lifecycle. The process follows a north-to-south flow, moving from commercial systems down to physical hardware. Phase 1, Order Capture and Validation, BSS layer, Order Entry. The customer selects a service, example a 5G data plan or an SD-WAN corporate link, via a portal or app. Feasibility check. The system automatically checks if the service can be delivered to the customer's location or if the required hardware is available. Credit and eligibility. Commercial checks ensure the customer is eligible and has passed credit vetting. Phase 2, Service Orchestration, OSS layer, Decomposition. The high-level commercial order is broken down into service orders. For example, a triple play bundle is split into internet, TV, and voice components. Resource allocation. The OSS queries the network inventory to find available ports, IP addresses, or virtual functions, VNFs. Workforce management. Optional if a physical installation is needed, like fiber to the home, a task is dispatched to a field technician's mobile app. Phase 3, Activation and Configuration, Network layer, Provisioning. Commands are sent to the network elements, routers, switches, or cloud servers. Network slicing. Modern 5G/6G. The system carves out a specific slice of the network with guaranteed latency or speed specifically for that user. Self-test. The system runs an automated loop-back test to verify that data is actually flowing correctly. Phase 4, Jeopardy and Fallout Management. Fallout handling. If a command fails, example a port is broken, the system triggers a fallout ticket. In 2026, agentic AI often attempts to self-heal or find an alternative route before involving a human engineer. Key components involved. Component function. CRM/BSS manages the customer relationship and the product catalog. Orchestrator. The brain that coordinates the sequence of events across different vendors. Inventory, SID, the single source of truth for what resources are currently used versus available. Southbound APIs. The translators that speak the specific language of hardware, Nokia, Ericsson, Cisco, etc. The 2026 evolution. Intent-based provisioning. Traditionally, provisioning was step-by-step, example do A, then B, then C. Today, operators use intent-based orchestration. 1. The operator defines the intent, example give this user 1 Gbps with 99.9% uptime. 2. The AI-driven OSS determines the best way to configure the network to meet that goal. 3. Closed-loop assurance constantly monitors the service. If performance drops, the provisioning process re-triggers automatically to adjust resources. Note, the goal for modern Tier 1 operators is zero-touch provisioning, ZTP, where the time from click to connect is measured in seconds rather than days. 5G core network provisioning process. In the 5G era, provisioning has shifted from configuring physical boxes to deploying cloud-native network functions, CNF. Because 5G is based on a service-based architecture, SBA, provisioning isn't just about turning on a line, it's about orchestrating microservices and network slices. The 5G core provisioning lifecycle. 1. Subscription management, UDM/UDR. The process starts at the Unified Data Management, UDM, and Unified Data Repository, UDR. The action, the BSS, Business Support System, pushes the subscriber profile, IMSI/SUPI, QoS profiles, and allowed SN size, into the UDR. The result, the network now knows who the user is and what they are allowed to do, example this user has access to the low-latency gaming slice. 2. Network slice selection, NSSF. In 5G, we don't just give everyone the same pipe. The action, the network slice selection function, NSSF, identifies which virtual partition of the core network the user should be attached to. The result, if a user paid for an IoT-only service, they are provisioned into a slice optimized for battery life, not high-speed video. 3. Session management and policy, SMF/PCF. This is where the actual connection parameters are defined. Policy control function, PCF dictates the rules. Example if the user exceeds 20 GB, throttle to 1 Mbps. Session management function, SMF. The conductor that manages the user's data session. It allocates an IP address and selects the best user plane function, UPF, to handle the traffic. 4. User plane activation, UPF. The user plane function, UPF, is the workhorse that handles the actual data packets. The action, the SMF sends provisioning rules to the UPF using the N4 interface, based on PFCP, Packet Forwarding Control Protocol. The result, the UPF is now ready to route the customer's TikTok videos or Zoom calls to the internet. Technical comparison, 4G versus 5G provisioning feature. 4G, EPC, provisioning. 5G core provisioning architecture. Point-to-point interfaces. Service-based architecture, HTTP/2 APIs, speed minutes, manual/scripted, milliseconds, zero-touch/API driven, granularity per device/APN per network slice, SNSI, control centralized distributed, edge computing/MEC, 5G provisioning under the hood, netconf and yang. While the high-level BSS talks via REST APIs, the actual configuration of the virtualized infrastructure often uses netconf and yang models. The relationship can be expressed by the logic that the total provisioned bandwidth is the sum of the individual network slice instances, whereas the bandwidth allocated to a specific slice based on the provisioned slot. The role of AI in 2026 provisioning. Today, we use closed-loop automation. If the 5G core detects a surge in traffic at a stadium, the NDAF, Network Data Analytics function, signals the orchestrator to instantly provision more UPF instances. This is provisioning on the fly without human intervention. Orchestration using MANO in 2026. MANO, Management and Orchestration, is the operating system of the telco cloud. While traditional provisioning was about configuring hardware, orchestration using MANO is about managing the entire lifecycle of virtualized and cloud-native services. Developed by ETSI-NFV, the MANO framework consists of three main components that work together to turn a business request into a running 5G service. The three pillars of ETSI MANO component. Official name. Role. The analogy coordinates the creation of network services, the big picture. It NFV orchestrator. The architect talks to the OSS. Manages the lifecycle of specific network functions, example of the project VNF Manager Virtual Firewall or 5G UPF. Manager virtualized infrastructure controls the underlying resources, compute, storage, network, VIM. The foreman manager like OpenStack or Kubernetes. The orchestration workflow, how it works. When a telecom operator wants to deploy a new 5G core slice, the orchestration follows the sequence. 1. Onboarding, the operator uploads a blueprint, descriptor, to the NFVO. This file defines what the service needs, example I need 2 CPUs, 8 GB RAM and a specific 5G software image. 2. Instantiation, the NFVO checks the available resources across different data centers. It then instructs the VNFM to start the specific virtual machines or containers. 3. Resource granting, the VNFM asks the VIM, OpenStack/K8s, to actually carve out the virtual space and spin up the instances. 4. Day 1 configuration, once the software is running, the VNFM applies the initial settings, IP addresses, security keys, so the network function can join the 5G network. Advanced orchestration in 2026. In current 5G/6G deployments, MANO has evolved beyond simple on/off switches, auto-scaling. If the VIM reports that CPU usage on a 5G user plane function, UPF, is hitting 90%, the VNFM automatically triggers the orchestration of a second UPF instance to share the load. Self-healing, if a virtual node crashes, the NFVO detects the failure and restarts a new instance on a healthy server without human intervention. Multi-domain orchestration, modern MANO can orchestrate services across different clouds, example moving a low-latency 5G function from a central data center to a far-edge server closer to the user. Transition to ZSM, zero-touch service management. While MANO handles the virtualization layer, the industry is now moving toward ETSI ZSM. MANO is great at managing resources, VMS, containers. ZSM is the intelligence layer above it that uses AI to make decisions on when and why to orchestrate those resources. Key takeaway, without MANO, 5G would be impossible to scale. It provides the automation needed to manage thousands of virtual functions that change by the second.